cubic equations and finding cubic equations, which is a subtopic of calculus, still under calculus, and this is our fourth lesson. So what is a cubic equation? We're looking at cubic functions, right? We're studying cubic functions, sketching cubic graphs. Right, so what's a cubic function? Cubic function is of the form f of x is equal to ax cubed plus bx squared plus cx plus d. Now, observing this function here, what does the value of a represent? The value of a represent the shape of the graph. So if a is positive, then we get a graph like this. Right? You're going to get a graph that has two turning points. That's a general shape of the graph, right? And if a is less than 0, then you will get a shape of the graph which is like this. The other way is basically flipped. Okay. So again, if a is positive, you're going to do max min. You're going to get a graph which is maximum first, then minimum second. And if a is less than 0, you'll get minimum, then the maximum. Now, before we do any analysis on this, what is the value of d? Again, the value of d, which is a constant, it represents the y-intercept. This value just represents the y-intercept. Okay, now before we do anything on the cubic functions, I want to go and look at the key features. What are the important concepts that we need to know in cubic functions? And what are the notations, right? So first, so looking at concepts, so x-intercepts and y-intercepts, x and y-intercepts. So let's look at this. What is an x-intercept? What is a y-intercept? So if I have a cubic function like this, I'm just going to give you a general graph. I'm not actually solving anything here, right? I'm just going to give you a general graph and we're going to look at that. What is the x-intercept? What is a y-intercept? So for x-intercept, we need to look at the x-axis, right? And for the y-intercept, we need to look at the y-axis. So let's just say these are some of the points that I have. Just to the other side, a little bit here. All right. So I've got -5, -1, and 2, right? And this point is -3. Now, x-intercept, for x-intercept, you're going to say, just say if this is a function f, right? So for x-intercepts, you're going to say f of x is equal to 0. If you solve f of x equal to 0, in this case, you will get 3 answers. You can clearly see x-intercepts is read off from the x-axis. So x-intercepts will be x equals -5 or x equals -1 or x equals 2, right? Y-intercept is saying f of 0, right? So if you substitute 0 inside the original function, which is a cubic function, ax cubed plus bx squared plus cx plus d, you get a constant value. So that is -3. So I hope you understand what f of 0 means. F of 0 means y-intercept. And f of x equal to 0 means is the x-intercepts. That's how you find intercepts, okay? So in this case, it was -3. So 0 and -3 is a coordinate of my y-intercept. Next important point. Oh yes, from this, there are three important things that we need to know. When is f of x greater than 0? When is f of x, okay, let's start with less than 0 first. When is f of x less than 0? F of x equal to 0. And when is f of x positive? And what does it mean when we say all these things? So f of x less than 0 means we are looking for below x-axis. When is a graph below x-axis? F of x equal to 0 means on the x-axis or the x-intercepts, right? And f of x greater than 0 means above x-axis. Okay, so if we want to solve these, of course we can solve it because we already have the points. So when is f of x less than 0? They will ask you questions like these, right? So that's why we got to do key features and try to understand from the important points that are given, what can we find? Right, so f of x less than 0 means when is a function below the x-axis? It is below the x-axis when the value of x is less than -5, when x is less than -5, or when it's between -1 and 2. It is below sea level, right? So think of x-axis as the sea level. Below sea level, it is less than -5 and between -1 and 2. Okay? So between -1 and 2, like this, right? Or you can write it in interval notation with round brackets. It depends on what's given here. If that was included, then all of these will be included. Now, this one here, when is f of x equal to 0? There's the three answers here is the same thing. So x is equal to, you can write it in set notation when it is -5, when it is -1, or when it is 2. You can write it as a set because you got multiple answers. When is f of x greater than 0? It is above the x-axis when it is between -5 and -1. So I'll write that in interval notation instead of writing it like this. It is between -5 and -1, or means union from 2 to infinity. If you don't like to write it like this, you can write it as -5 to -1, or x is greater than 2. Okay, so when is think about the dolphin that swims, right? So less than -5 is below sea level, is underwater, then it jumps, right? In this form. So above water is from -5 to -1, and then it is below water again, and it jumps again. So after 2 is just there and kind of like stopping that function. Right, so we are good. So those are the three important notation. You need to understand what is f of x less than 0, f of x equal to 0, f of x greater than 0. Now let's look at the next part. Next part is very important key feature as well, which is called stationary points. Right? Stationary points and looking for increase and decrease. Increase and stationary points. Okay, we can look at the increase and decrease later. Let's just talk about stationary points. And max and minimum values. Now, how do we find stationary points, maximum and minimum values? That's our next key feature. To find stationary points, maximum and minimum values, we got to look at the derivative. And why we say we got to look at the derivative? Because, right, let me copy the function. No, not really. Let me just draw a cubic function, all right? let's just say if your cubic function looks like this, right? I'm just taking a positive cubic function and I'm just putting some maximum and minimum values here. Let's just say if this max value here is -3 and 10, and this value here is 2 and -4, for example, right? Now, if you follow this path, right, you have to go from left to right. Okay, you read off from left to right. So if you go up, think about the roller coaster. If you go up, then you find yourself stationary at this point here. Okay, so you're initially going up, then you're finding yourself stationary at this point, right? And you find yourself stationary at this point. Now, what is a stationary point? You can see stationary point is a horizontal tangent, right? So now what's the equation of this? What's the equation of this line? Y equals -4. See, what's the equation of this line? Y equals 10. But what we find over here is that this is a horizontal tangent, okay? The gradient of the horizontal tangent is 0. This implies that f prime, the gradient is 0. In other words, the gradient function is 0. So f prime x is equal to 0. Now, what is the value that goes there? What is the x value that goes there? You're saying f prime x is equal to 0. We need to say f prime 2. The derivative at 2 is 0. Okay? And same here. The derivative here is also 0. So see, we say f prime x. So let's write f prime x equal to 0. Okay, it's fine. Let's write derivative at 2. This implies that f prime x is equal to 0. Same here. Over here, we're going to say f prime -3 is equal to 0. Okay, what's the reason why we say this? Because the slope or the gradient at this point, at the maximum and minimum point, is 0. What's the gradient of a horizontal line? It is 0. But now if you try to go here, obviously this part over here has a gradient. You can see it's increasing, right? And then if you go down here, you can clearly see that it is decreasing, okay? So when is it horizontal? So when we have horizontal tangents, it means that we are finding maximum and minimum values. And you know when the graph is sad, it is maximum, and when it is happy, it is minimum. So this is the maximum point, right? And this is the minimum point. So what did we learn from here? Now, question is, how do we find a stationary point? To find stationary point, we need to say f prime x is equal to 0. Now, if you try to solve f prime x equal to 0, right? If you try to solve f prime x equal to 0, you are basically finding the derivative of the original function and making it equal to 0. In this case, we're going to get two answers. The two answers are -3 and 2. So we will get x equals -3 or x equals 2. If I substitute -3 into the original function, I'll get y is equal to f of -3, and that's going to give me 10. Or y is equal to f of 2, and that's going to give me 4. So we have two coordinates. The two coordinates are -3 and 10, or 2 and 4. Because remember, this is a point on the graph that gives a stationary point. So what is f prime x equal to 0? That's to find stationary points. Right. Another word for stationary points is also called critical values. We can also call it critical values. Now, what do stationary points and critical values represent? We can get maximum and minimum values. Compare now. Which value is a maximum? You can clearly see comparing 10 and 4. So 10 is the maximum, right? And what is 4? 4 is the minimum value. Now, you remember before what we have done. We have done f prime x, f of x less than 0, f of x equal to 0, f of x greater than 0. So that's what I'm going to do now for the next part. Now I'm going to say f prime x. Now I'm going to say f derivative x less than 0, f prime x equal to 0, and f derivative is positive. So what do these things mean now? Anyone knows what that means? See, f prime x less than 0 means, what does f prime x represent? The gradient function. So I want to know when is the function decreasing. So what does this mean? It is decreasing. When is the graph decreasing? F prime x equal to 0 means when is the function stationary? And f prime x greater than 0. F prime x, what does f prime x represent? I told you many times, f prime x, think of it as a gradient function. When is a gradient positive? In other words, when is the function increasing? Okay. So those are the three concepts. Now we have to solve them. You can't just leave it like that. Now solving them, when is the function less than, when is this function over here decreasing? It is decreasing between, now remember these things can also appear in maths paper 2, these notations. So they can ask you, instead of asking you when is the cos graph or the sine graph decreasing, they will say when is f prime x less than 0. So you must know that this here means decreasing. When is the function decreasing? Slope negative means decreasing. So it is decreasing from -3. You're going down. Think about the roller coaster. You're reading from left to right. So you went up, stationary, down, then up again. So it is decreasing between -3 and 2. Right, that's my answer. When is it stationary? It is stationary at -3 or x is equal to 2. Mishka, you want to try the last one out? When is it increasing?
Um, would it be when x is less than -3?
Yes, x is less than -3, or I have
Or when
another
it's
increase. Good.
bigger than 2?
Yeah, excellent. Remember, you can also write this out in interval notation. You can say x is an element from -infinity to -3, union 2 to infinity. But this is a bit complicated. Don't use interval notations in maths paper 1. Try to use interval notation in maths paper 2 when you are working with trigonometry and stuff, because you have many multiple different answers. Okay, so that's why I rather just prefer to, inequalities. It's much more simpler. Let's leave that out. Right. So what did we learn now? Very two important stuff. We learned everything about f of x when it's positive, negative, right? Just means below and above the x-axis. Now we learned about stationary points. When will it give us maximum? When will it give us minimum? Right. Next thing, we also learned about increasing and decreasing and the notations. What's the next key feature? The next key feature is inflection points, right? Inflection points. Uh, Inflection points, and then we have concavity, right? Now, remember, a cubic function has two important things, right? So remember, this is concave down, right? What is this? If a graph is just sad, it's only sad, okay? It is concave down. And when the graph is only happy, like a quadratic function, right? This is concave up. Right. So, but now in a cubic function, we don't have concave down and concave. We have a mixture of both. So what we're going to do now is we're going to combine these graphs, right? So what I'm going to do is watch here. I'm just going to change this into a different color and combine these two graphs. Right. See, this graph is here, okay? Now I'm moving this part here, concave up, right? Let's just call this change it to green, right? And what was this part here? Concave down. Keep it there. And this is concave up. And if I mix both, see what's happening. See where this point is. Watch this point here. This point over here where the concavity changes. Concavity changes. Right. Where this is the point where the concavity changes, and this point here where the concavity changes is called the inflection point. Inflection point. Now, how do we find the inflection point? To find the inflection point, we find the double derivative f double prime x, and we make it equal to 0. Okay? So now let me just put an inflection point over here now. So think about this function. So I'm going to continue this graph, and I'm going to continue this graph as well. I will just give you the inflection point for now, but we will find it from the original. Just say if the inflection point is 1 and 3. Okay? Now f double prime x equal to 0. In this case, the x value will just be 1. Okay? That's the inflection point. Now, how do I find the y value? To find the y value at any point on the graph is always to substitute into the original function. So y is equal to f of 1. In this case, you will get an answer of 3, right? Because I just made this into a function. So remember what an inflection point is? It's a point where the graph changes from concave down to concave up, or from concave up to concave down. Right, so this is my inflection point. Inflection point is at 1 and 3. This is my inflection point, IP. Now, remember before what we said? We need these three important information again. Now we are working with double derivative. So what do we want now? We want the double derivative. So f double prime x less than 0, f double prime x equal to 0, and f double prime x positive. Now, what does each one mean here? So what each one means is f double prime x less than 0 means concave down, right? F double prime x equal to 0 means inflection point. And f double prime x greater than 0 means when is the graph concave up. Now, when is the graph concave down? Look at this graph that I gave you. It is concave down when x value is less than 1. Isn't it? When the x value is less than 1, there's the x value here. When it is less than 1, then the entire graph is concave down. We're not looking for increase, decrease, guys. Very important. We're looking for the entire happy phase and the entire sad phase. So we're looking for the entire sad phase. Concave down means the entire sad phase we are looking for. We're looking for all of this. When does all of this occur? When it is less than 1, when the x value is less than 1. When is the inflection point? When the x value is equal to 1. When it is concave up, when it is greater than 1. Are we good? Or now, does that make sense?
Yes.
So what did we learn? We learned something about f of x. It's just above and below the x-axis and on the x-axis. Then we learned about when the function is increasing, stationary, and decreasing, right? And now we learned about inflection point. So the important key features. Next one is about roots, right? So we say f of x is equal to k. Now, remember, when we say f of x is equal to 0, when we say f of x is equal to 0, it means x-intercepts, okay? Now, what happens when we say f of x is equal to k in a cubic equation? So I'm going to draw a cubic equation here. And what's the type of questions that you get here? They say find the value or values of k such that f of x equals to k will have distinct roots. Distinct roots, or they say unique roots, means the same thing, or they say three distinct roots. B, each of these mean the same thing, real roots. And C, one real root. Right. So those are the three types of questions that you can get in roots. Now let's look at the setup. The setup is you only need to look at the turning points, right? You only need to look at the turning point y values. So let me just put some points here like -3 and 10, 2 and 4. Now, remember this is the function f of x. How can I cut the function f of, now remember I need answers for a, b, c, right? So the answer for a is, okay, this is my cubic function. How can I get three distinct roots? How can I get three different answers? How can I get three different x-intercepts? How should I cut the graph? So if I cut the graph in between the turning points, can you see? So watch this. If I cut it anywhere between the turning points, I'm getting three roots. What does the three roots mean? It's cutting the graph three times. 1, 2, 3. Now, no matter where I shift this graph, see, what happens if I shift it above the turning points? It's not cutting the graph three times now, it's only cutting the graph once. So we don't need an answer. That answer will be one real root. You see, what's happening at the turning point? If I'm moving the x-axis there, now I'm getting two answers here. One, I'm just getting a real roots, okay? Now, if I move it here, okay? Now we can see we are getting three distinct roots. Distinct means different. It means unique. Okay. So you can see if I move this lines everywhere, you can see it's only cutting the graph once now. If I move it below the lowest point, below the turning point, above the turning point is one real root. Okay. On the turning point is just three real roots or real roots. Shouldn't be saying real roots. Let's just say three real roots. So what are you looking for in these cases? Because they said f of x is equal to k, you are only looking at the y values. So how should I cut the graph here? What should the value of k be over here so that you're going to get three real roots? The value of k should be between 4 and 10. So the value of k should be between 4 and 10. Now, where is 4 and 10 coming from? Is coming from the turning point y values, okay? You only use the turning points here. So when you solving roots, try to use the turning points. Next one, because you are working with y values. Remember, the value of k is a y value. You're solving for k here. Those are y values. Okay, great. Now, B, when you will get three real roots? Easy, three real roots is from 10 to 4. So from 4 to 10. It's just including here now. That's the difference. This is for real root. This is for distinct. This is for distinct, right? This is for real. And part C, one real root. When will you get one real root? When it is above 10 and below 4. When the value of k is less than 4, or when the value of k is greater than 10. Any questions, guys? Does that make sense? Arnav, we good?
Yes, sir.
Right, excellent. Right, so I like these types of questions, which is good. Right, so those were the four important things that you need to know. What are they? X and Y intercepts, stationary points. From stationary points, what can you get? Increase, decrease, min, max values. Then concavity. From inflection points, what can you get? You can get concave up, concave down, and roots. Right, now we can start with our cubic equation. So the cubic equation that we want to solve is this. We want to sketch the graph of this. Now, there's a process in sketching the graph. So if you're looking at all of these questions, see what is asking you for. We have a cubic equation, right? We have a cubic equation, which is 2x cubed plus 5x squared minus 4x minus 3, right? And now we want to sketch this function. Now, how are we going to sketch this function? First, we notice that, okay, this is 2. So I know my graph will be this shape. The shape of my graph will be like this. But anyways, that's just a starting point. That's the shape of my graph. So let's find the intercepts. Let's find the x and y intercepts. So A, we know y-intercept. Y-intercept is just -3. So 0 and -3, right? The constant value. What's the x-intercept? X-intercept is where you have to do most amount of work. You need to make f of x equal to 0. So you need to say 2x cubed plus 5x squared minus 4x minus 3 is equal to 0. So now, how do you solve this equation? You have to open up one small bracket, one big bracket, right? This is a setup. Then 3 brackets, right? You have to show this second step, very important. Okay, you can't leave it out. And then last, x equals or x equals or x equals. So let's use our calculator and solve this. Obviously, there are other ways of solving. You need to choose factors of 3 and substitute the different rational roots. Factors of 3, factors of 2, so you need to take that over that opposite signs. Anyways, what we're going to do is mode 5, 4. What's the value of A? 2. What's the value of B? Next to x squared is 5. Value of C, -4. Value of D, -3. And see if we are getting answers. Yeah. So we're getting -3. We're getting 1. And we're getting -0.5. Right, so we have 3 answers. Right, so you saw that 3 answers. Now, how do we push it back inside this function? So you're going to take this onto the other side. This becomes x plus 3. You're going to bring this to the other side. That becomes x minus 1. You're going to bring this to the other side. That becomes 2 times x is 2x. And then bring the 1 over plus 1. Okay. You copy the same thing above, x plus 3. You have to open up all this. So 2x times x is 2x squared. Right, and then x times 1 is plus 1x minus 2x is minus x and minus 1. You have to show this step, okay? If you don't show that step, I'm just showing you how to use a calculator to cheat and solve this, all right? There is a forward method. The forward method is to choose the different factors of 3, substitute, and factorize them, okay? But this is the fastest way, and you should just stick to this method, all right? Are we good, guys? Make sense? What did I do with these two factors? I just opened them. So now we have 3 x-intercepts, okay? We have a y-intercept. Next thing, find the stationary point. We need turning points, otherwise we can't sketch the graph. Find the stationary points and intervals of increase, decrease. Okay, after we find the stationary points, then we can see when it is increasing and decreasing, right? So B. What is the stationary point? First, we need the cubic equation because we need to differentiate. Right, so we have the cubic equation, which is f of x equals, right? So what is the derivative? For stationary point, we need to say the derivative must be equal to 0. So I'm going to make that equal to 0, right? So what is the derivative? Let's put the derivative here. This is for stationary point. And why is the derivative, why is it equal to 0 for stationary point? Because the gradient at the stationary point is 0. Gradient of the horizontal line is 0. That's the reason why. Okay. Or you can look at this gradient equal to 0, right? So that's what you find. You're finding the maximum and minimum points here. So 2x cubed plus 5x squared minus 4x minus 3. So 3 times 2 is 6. We have 6x squared. Take away 1 from the power, okay? Power times the number is plus 10. Take away 1 from the power, 10x. Minus 4x minus 3 is a linear function. The slope is just negative 4. Or the gradient is negative 4. Now, if you simplify this entire thing, you will get 3x squared plus 5x minus 2 is equal to 0, writing it in standard form. I don't know whether if you can factorize this or not, so we're just going to use a calculator and substitute mode 5, 3. So 3, 5, and negative 2. Let's see if you can, okay, so we can factorize this. So we're going to open up 2 brackets again. Right, so we got x equals 1/3 or x equals negative 2. Right, so x equals 1/3, we have 1/3, so x is going to become 3x minus 1. And take this minus 2 over, that will become x plus 2. So now we have 1/3 and negative 2. Right, now if you think about the shape of the graph, where should 1/3 be and where should negative 2 be? So obviously negative 2 should be on this side, right? And where should 1/3 be? 1/3 should be on the right of negative 2. So that should be 1/3. So we can clearly see from the critical values or from the stationary points that we know exactly which one is minimum and maximum because of the value of A, because of the shape of the graph that we know. So we can say that negative 2 is already a maximum, and we can say that 1/3 is already a minimum from what we know from the shape of the graph. We already know that the minimum occurs at 1/3, and we know that the maximum occurs at negative 2. But you can also substitute into the original function. That's what you should do. You should substitute 1/3 into the original function. So y is equal to f of 1/3. Right, so I need someone to calculate what is f of 1/3. You're substituting 1/3 in the original function because it's a point on the graph. No use substituting 1/3 into the derivative because that will give you 0. Okay. So you have to substitute 1/3 into the original function. So let's do it together. 2 into 1 over 3 to the power 3 plus 5 into 1/3 to the power 2 minus 4 into 1/3 right? And then minus 3. And I'm getting negative 100 over 27, which is 3.7. Negative 100 over 27. I'm getting negative 100 over 27, which is negative 3.7. So what's my what's my we said this is a minimum value, but let's compare both the y values. You can also use y values to compare instead of using those points. Uh, so 1/3 is giving me negative 3.7. Right? Let's look at this value here. Y equals f of negative 2. I need to substitute negative 2 and see what's the y value there. Negative 2. Negative 2. Negative 2. Right, so I've changed all three and I'm getting 9. Right, so negative 2 is giving me 9. And now you can clearly see if you compare these two values, negative 3 and 7 and 9, you can clearly see 9 is the maximum and negative 3.7 is a minimum. You can see minimum, and this is also a maximum, which confirms, right, our original idea. So anyways, those are the two coordinates. So right, so we can say critical values, stationary points. What are the stationary points? Stationary points is when f prime x is equal to 0, and that's giving me x equals 1/3, or x is giving me negative 2. Then they ask for intervals of increase and decrease, right? So when is it increasing and when is it decreasing? So you're going to say increase. Increase is when f prime x is greater than 0. So we are looking for when the graph is sloping upwards, right? When it is positive slope. When is the graph positive slope? When it is less than negative 2. Or when the graph is more than 1/3. Right. So when the graph is after 1/3, it is sloping up. When is it decreasing? It is decreasing when f prime x is less than 0. Okay. So you're looking for a graph when it is sloping down. So the graph is sloping down between -2 and 1/3. And you know, when you're writing interval notation or inequality notation, the smaller number goes on the left and the bigger number goes on the right. Okay, so that's my answer. Are we good? Misha, we good? Enough?
Yes, sir.
Right, excellent. So it's quite simple. Now, remember, we need to use all these key. We kind of like already sketched the graph. There's a graph here. All we need to do is just put x-intercepts, right? So find the points of inflection, concave up and concave down. So hence sketch the graph of f of x. Let's find the points of inflection. So we need to say we had f of x, right? And we had f prime x. So we had both these two things. Now we just need to find what is, so we got f of x and f prime x. We need to find double derivative, right? So we need to find double derivative. So let's take this out. Remember, you can't say is equal to 0. For concave up or concave, for inflection points, you need to say double derivative is equal to 0. So not even the simplified form of the first derivative. This is the first derivative, the original form of the first derivative. I need to find the double derivative. So 2 times 6 is 12. Take away 1 from the power, which is x. Derivative of 10x minus 4 is just plus 10 because that's linear finding. Right, so now we're going to make this equal to 0. So we get 12x is equal to negative 10. X is equal to, you can divide both sides by 2, you're going to get 5 and 6, negative 5 over 6. Okay, or minus 10 divided by 12 is minus 5 over 6. So what's a y value? Y value is now equal to f of negative 5 over 6. Oh man, we need to substitute negative 5 over 6 into the f of x function because we want the inflection point, all right? Now, where does the inflection point lie? Watch here. The inflection point is somewhere around here. That's where the concavity is changing. It's going from concave down to concave up. Can you see? So that is negative 5 over 6. This point over here is negative 5 over 6. And what's a y value? I need to substitute negative 5 over 6 inside here. Lucky I've got this. So that's negative 5 over 6. That's negative 5 over 6. And that's negative 5 over 6. Right, so I'm getting 143 over 54. I'm getting 143 over 54, which is approximately equals to 2.65, 2.65, 2.65. Right, so my inflection point is negative 5 over 6 and 143 over 54. It's fine if you write it like this. It's better to write it in fractions than to write it in. The only reason why we write it in decimal values so we can find the exact location of that point, right? Because 143 over 54 doesn't make much sense to us because we still got to divide by 54. Anyways, this was to find the inflection point. Always use the double derivative, set it equal to 0, and then you will find the inflection point. But note, there is another way to find the inflection point. You can take the stationary points, okay? The two stationary points, so inflection point x value, right? How do we find the inflection point x value? You can take stationary points, right? So we can say stationary point 1 plus x stationary point 2 and divided by 2. So what was my first stationary point? It was negative 2, right? Plus, what was my second stationary point? It was 1/3. And if I divide it by 2, see what you get? Negative 2 plus 1 over 3, and we're dividing it by 2. We're getting negative 5 over 6, right? But you can only average it for finding the x value. Now to find the y value, remember that's a golden rule. Always to find the y value, you have to substitute into the original. So you got no option. That's why I don't like to use this method. I like to use the double derivative method, okay? So that's negative 5 over 6, but still it is still a method, right? So that's the reason why I'm showing you another way to find the inflection point. Inflection point is where the graph changes from happy to sad, or where the concavity changes. That's the meaning of inflection point. Right, and now to find the y value, you have to say f of negative 5 over 6, and then you will get 143 over 54. So my inflection point is now negative 5 over 6 and 2.65. If you want, you can write this answer down as well. Negative 0.83 was 5 over 6. 5 divided by 6 is 0.83. Yeah, so negative 0.83. Right, so that's my inflection point, negative 0.83 and 2.56. Now we are ready to sketch the graph. Wait, by the way, remember I also asked for when is the graph concave up, concave down. Okay, when is the graph concave up, concave down? So we can look at that. So inflection point, let's start with the inflection point first. Inflection point. Inflection point is when f double prime x is equal to 0. So I'm getting x is equal to the x value of the inflection point, right? Inflection point is a point. What is a point? A point has two properties. It must have an x value and a y value. So when we say inflection point, what I mean over here is the x value of the inflection point here, okay? Because the question will clearly specify. The x value of the inflection point here is -5/6. When is the graph concave up? The graph is concave up when f double prime x is positive. In other words, we are looking for happy face. Now, where's the graph happy here? When the graph is after -5/6, the graph is happy. So x is more than -5/6. So what's the answer for this? X is more than -5/6. Over here, concave down. Right, so when is the graph concave down? When the graph is sad, right? Or when the graph is sad like this, right? So the graph is sad when x is less than -5/6. Let's check that out. Yeah. Right, so now we are ready to sketch the graph with all the key features. So let's start with putting the x-intercepts first, right? Now comes the sketching part of the graph. It's easy to sketch, right? Right, so what we had here was my x-intercept. My x-intercept was, let's see, -3, 1, and -0.5. -3, we had a -0.5, right? And we had a 1. Remember, the graph is not drawn to scale, please. Don't draw graphs to scale, all right? And my y-intercept was -3. Okay, so my y-intercept was -3. I'll just go down here, right? Look, when you're sketching your graph, you need x-intercepts, y-intercepts, and turning points. Fit that in first and then do the rest. And then just put an inflection point. That's it. Turning point was -2 and 9. So at -2, we had 9, okay? So we had a turning point at -2 and 9. -2 and 9, we had a turning point. And we had another turning point at 1/3 and -3.7. So 1/3 and -3.7 will just be down over here, right? So let's just say this is 1/3 and -3.7, right? And now we are ready to sketch the graph because the graph will go through half, right? So you know this graph is turning like this, right? And you know this graph is turning upwards, right? So it's going to turn upwards and go through 1, okay? This graph is going to turn here, go through half, turn there, and hit it at -3 and come down, okay? So just try to draw your graph properly. It's going through that, yeah. Right, so this is my graph of f. It shouldn't be a straight line, it's a curve, right? Yeah, just make sure how you're sketching the graph. That's a curve. Right, so this is my graph of f. And remember, we also found an inflection point. Inflection point was at -0.83 and 2.65. There, -0.83 and 2.65. So it's somewhere around here. That's where the inflection point is. Okay. So we're going to represent that as inflection point. And 2.65. Right. So all the important features are here. And that's great. That's my sketch of the function. So what's important in sketching cubic functions is x-intercepts, y-intercepts, turning points. That's it. And sometimes they will ask you a question on inflection point. Are we good, guys? Right, so let's look at the next question now. See what they say. Just sketch the graph of f of x. Right. I just want to sketch a graph of f of x and just show all these 4 points here. I don't need to worry about increase, decrease, and all these things. So let's look at this function here. We can see that this is a negative cubic, right? Negative cubic is of this form. Okay. Right, so that's the shape of the graph of a negative cubic function. Right, so let's do all the analysis on this. Let's find the x. We already know the y-intercept, right, which is the easiest. It is 0 and 3, right? The x-intercept now, we need to make the entire equation equal to 0. So minus x cubed plus x squared plus 5x plus 3 is equal to 0. Write this equation in standard form. So you're going to get x cubed minus x squared minus 5x minus 3 is equal to 0. Let's check if this here factorizes, then we can open up our brackets and see, okay, it's fine. Open one small bracket, one big bracket, then three small brackets because you've got three different answers, right? And then x equals, x equals, x equals, right? X equals, or x equals, I don't know how many x equals I'm going to put here, but anyways, let's go. Mode 5, 4. So we have 1. You're substituting all these values, right? So 1, -1, -5, and -3. So I'm getting 1x value as 3. I'm getting -1. I'm only getting 3 and -1. So now what you're going to do in this case? All right, so you're going to say, take this 3 over x minus 3. All right, you're going to take the x, or you're going to take this -1 over, you will get x plus 1. Now, see what's happening here. You got -3, all right? So you need this value here. You need the product of all the constants to be -3. So I got -3 times 1 is -3. So in other words, this here should also be a 1 there. So it's -1 twice. So x is equal to -1 twice. Right, so why it is -1 twice? Because -3, if you're going to make 3 twice, then it's going to become 3 times 3, which is 9. So -1 is appearing twice. So we're going to say x plus 1. Okay, so what you have here is x minus 3. Open up these two. It's a binomial, x squared plus 2x plus 1. Right, and that's a way to factorize using your calculator. Are we good, guys? Mishka?
Yes, sir.
All right. So now this was finding the x-intercept, right? So after you find the x-intercept, wait, let me just push this to the side here. Right. So now we have our x-intercept sorted out. Now, whenever this happens, whenever you get a case of something like this, you'll find that your turning point is on the x-axis. You'll always find that the turning point is on the x-axis. You'll always find this. So you will see why the turning point is on the x-axis whenever you have a repeated root. This is a repeated root. What's a root? Solution to equations. So this was a repeated. Anyways, let's find the next part, which is stationary points. We found the y-intercept, we found the x-intercept, now we're finding stationary points. Right, for stationary points, we know f of x. We already know the function f of x is we need to find the derivative, right? So what's the derivative of this? We say f prime x is now equals to -1 times 3 is -3. Take away 1 from the power x squared. 2 times 1 is +2. Take away 1 from the power x. Derivative of 5x plus 3 is just 5 equals 0, right? Now, why are we saying this? Because this is linear. What's the slope here? 5. Now, write this in standard form. That is 3x squared minus 2x minus 5 is equal to 0. Now, factorize this. It's going to factorize into two brackets, which is 3x and x equals 0. I think you get x is equal to, I don't know, I think you're going to get 5 here and a plus 1 here. Maybe minus, yeah. So 5 over 3 or x is equal to -1. So you can see -1 appears in the x-intercept and it also appears at the turning point. Factorize this and see. See if it's 5 over 3 and -1. Let's check. So you're going to go mode 5 and quadratic equation, which is 3. So you got 3 minus 2 and minus 5. Okay. So I'm getting 5 over 3 and -1. Yeah. Right. So now since x is equal to 5 over 3 and x is equal to -1, no need to worry about -1 because if I substitute -1 into the original function, I will get 0. And that's the whole idea of writing this out. So y is equal to f of -1 and f of -1 gives me 0. There's it here. F of -1, you're substituting -1 into this equation, it's going to give you 0. So the only thing that you need to find out is what is y equals f of 5 over 3. Right, so I need to substitute 5 over 3 inside this equation here. In the original equation, right? So negative into 5 over 3, negative into 5 over 3 to the power 3 cubed, right? Plus 5 over 3 to the power 2 plus 5 times 5 over 3, right? Plus 3. So we're getting 256 over 27. And now if you compare these two values, which one is minimum, which one is maximum? You can clearly see this is max and this is min. So this is the max value and this is the minimum value, right? So we have a coordinate of the turning points. The stationary points are 5 over 3. Oh yeah, by the way, 5 over 3, we put 1.67, all right? And 256 over 27 is basically 9.48, 9.48. 9.48, right? And this is just -1 and 0. Next part is inflection point. So you saw the shortcut method of finding how to sketch a graph. So we have stationary points and we have x and y intercept. Now we're just going to find the inflection point. Inflection point. Remember, we had the first derivative, okay? We had the first derivative, which is this. So I'm finding double derivative. F double prime x is equal to 2 times -3 is -6x plus 2 equals 0. So I'm going to say -6x is equal to -2. So x is equal to -2 divided by -6 is 1/3. So I need to substitute 1/3 inside here in the original function. 1/3, 1/3, and 1/3. So I'm getting 128 over 27. So I'm going to say y is equal to f of 1/3, which is 128 over 27, which is equals to 4.74. Right, so my inflection point is now at 1/3 and 4.74. Remember, what are these? These are max and min values. So maximum at, and this is the minimum value. Now, what we're going to use all this information. I'll put inflection point in last, right? I will use all this information to sketch this graph. Right, so I know the shape of the graph is like this, right? So let's start with the x-intercepts. Right, so we said the x-intercept was 3 and -1. And it was 3, right? Three and -1, so x-intercept is done. What's the y-intercept? Y-intercept was 3. But I have 9.48. Let me try to shrink the y-intercept, bring the y-intercept lower down, right? Y-intercept is 3. So my x-intercepts are done, my y. Now let's look at minimum and maximum. You see, when this is a maximum, maximum means it's a sad face, right? Maximum means is some kind of face like this. Minimum means is a happy face. So at -1 and 0, at -1 and 0, we have a happy face, right? It's a minimum. And at 5/3, which is 1.67 and 9.48, we have a maximum. So 1/3, sorry, not 1/3, 5/3, 5/3 and 9.48 is there. And we got 256/27, right? We have a sad face and we have a maximum. So do a maximum thing like this, right? Now, if you try to join all the important points, you'll find that you don't have an option. You got to join it like this, right? Don't join it like a straight line form now, right? It's like what I'm doing. Okay. And that's my cubic function. All right. And now I've got all the important points. That's -1 and 0. That's the x-axis. That's the y-axis. Where's my inflection point? My inflection point is clearly somewhere around here. Right. So which is 1/3 and 4.74. So everything works out perfect. All right. I'm just writing IP there to represent inflection point. And you can see the inflection point is written down here. And that's my cubic function. Does that make sense, guys? Or not? We good?
Yes. All right, so we sketch one positive graph, one negative graph. Okay, here's another graph to sketch. Quick sketch, right? We're gonna work very fast. So what we have is y-intercept is 0 and 14. X-intercept, we need to make this entire equal to 0. So x cubed minus 8x squared plus 5x plus 14 is equal to 0. So I just want to see if this works out. Mode 5, 4, 1 minus 8, 5 and 14, 7, 2 and -1. So it does work out. So bring it over x minus 7, x minus 2, x plus 1, x minus 7. Open this up. We get x squared minus x minus 2. Right, so that's my x-intercept, y-intercept. Now I'm finding the stationary points, SPs. Right, stationary points, f prime x. F prime x will give me 3x squared minus 16x plus 5 equal to 0. Let me see if that works out. 3 minus 16 and 5. Yeah, so it does work out. X equals 1/3 or x equals minus 5, I think. X equals 5, not minus 5. 1/3 and 5. So bring that over, you're going to get 3x minus 1. Bring that over, you will get x minus 5. Remember to multiply because we have a denominator. Only problem over here is to find the y values of the turning points because that's 1/3. Remember the shape of the graph is like this. Right, that's the shape of the graph. So we know 1/3 is first, so that's the maximum, and that's the minimum. Maximum and minimum. Right, so we can say y is taking 1/3 and substituting into the original equation. So we're substituting 1/3 into the original, 1/3, wait, 1 over 3 to the power 3 minus 8 into 1 over 3 to the power 2 plus 5 into 1 over 3, okay, plus 14. So I've got 400 over 27, right? So that's equals to 400 over 27, that is 14.81. And if I substitute 5 inside the original function, and change this to 5 now. One more 5 to change. Right, so I've got negative 36. So you can clearly see that at negative 36, 5 and negative 36 is a minimum, and 1/3 and 14.81 is a maximum, which conforms to our shape of the graph as well. Right, so that is sorted. We got so we got 1/3, 0.33 and 14.81, and this is my maximum, and my minimum is at 5 and negative 36. Right, so now finding the inflection point. Look, not always you need to find the inflection point unless the graph tells you to. So I'm not going to find the inflection point now because you know what to do. It's just basically double derivatives. So let me sketch the function now without the inflection point. So I have 7, 2, and -1. -1 is here, 7 and 2. So 2 and 7. Right, so those are my x-intercept. My y-intercept was 14. Right, next point, important point over here was 1/3 and 14.81. 1/3 and 14.81 is just above there, and that graph is happy, right? So if it's happy, it'd be like this. Sorry, it's a sad. It's a maximum graph. Maximum is like this, minimum is up. Then 5 and negative 36. 5 and negative 36 is right down here, and that graph is happy, right? And so now you don't have an option. You got to join at -1, right? You got to cut that graph at 14, go through 2, come down, join up here, right? And go through 7 and up. That's it. I just try to neaten this part here up, right? because you need to show a vertex. So that's a turning point here, which is 1/3. Whoa. 1 second. X was 1/3 and 14.81. I put negative 1/3. That's why the graph is looking a bit off, right? 1 second. It's 1/3, not negative 1/3, right? And move 14 to the other side, yeah. Yeah, so watch. It's 1/3, so the graph is turning up there and then coming down, right? This is 1/3 and 14.81, not negative 1/3, right? So you can see this graph is coming down here. Right? And then it's coming down to 2, coming down, up, and away. Right? And this is a graph of F. Put the inflection point if they ask you for. If they don't ask you for inflection point, it is just x-intercept, y-intercept, and turning points. That's it. Those are the important key features on the graph. The features of a graph, right? And you can clearly see at 5 and negative 36, that's a minimum and that's a maximum at 1/3 and 14.81, or 400 over 27. Next. Right, so we have an easier function to sketch. Look, we did a positive graph. Let's do a negative graph, right? I'm going to change this function a bit and make it negative x cubed, right? Plus 6x squared. I just did a positive graph now. Let's do a negative graph. So let's sketch the graph of g of x, which is negative x cubed plus 6x squared. So we're going to find the x-intercepts first. What's the y-intercept? Y-intercept is just 0, 0, right? There is no, if you substitute 0 inside this function, you will get 0. So 0, 0. What's the x-intercept? The x-intercept is making this entire equation equal to 0. So minus x cubed plus 6x squared is equal to 0. So what we need to do is write it in standard form first. Then take out HCF, highest common factor, which is x squared into x minus 6 is equal to 0. Now solve. X is equal to 0. But remember, x is equal to 0 what? Twice. Or x is equal to 6. Now we're finding the derivative, stationary points, right? What is stationary points? F prime x. And we need to make that equal to 0. So what's the f prime x? Minus 3x squared. How we got that? Take away 1 from the 3 times negative 1 is negative 3. Take away 1 from the power. 2 times 6 is 12. So plus 12. Take away 1 from the power. So plus 12x. Write it in standard form. Divide everything by negative 3. Divide by negative 3. If I divide everything by negative 3, I will get x squared minus 4x equals 0. 12 divided by negative 3 is minus 4. Take out x as a common factor. You're left with x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. So if x value is 0, the y value will also be 0. Right? But if the x value is 4, you need to find f of 4. So what is f of 4? Putting 4 inside the original equation. What's the original equation? This one here. So that's minus 64 and 6 times 24. So say minus into 4 to the power 3 plus 4 into 4 squared. Hey, we're getting 0 here as well. All right, so we got 0, 0, right? Or 4, 0. Now it's important. Look at 0, 0. 0, 0 is, look at these two y values. This is 0 and that is also 0. So you can't really make a comparison here, which one is min-max. But we can actually look at the shape of the graph. The shape of the graph is like this, okay? If I substitute 4 inside, no, I think I made a mistake here. It's supposed to be 6 times 4. It's not 40, sorry. Yeah, there's a 6 here. See what I have entered. Supposed to be 6 times 4. Yeah, so that's 32. Right, so we have a minimum here and we have a maximum here. So see, 32 is maximum, is more than that value. So we know 32. So this is the minimum and that's the maximum. Now we can sketch the graph, right? Because it's simple. I'm not finding inflection point, by the way, all right? Inflection point, if they ask you, then you put it, otherwise you don't. In this case, I'm not putting inflection points because that's easy. Just double derivative, make it equal to 0, and where the concavity is changing. Anyways, this is 0, right? And at this is 0 and y-intercept is also 0, and this is 6, right? What's happening at 0, 0? 0, 0 is a minimum, so the graph is going to be like this, okay? And at 6, 6 is just the x-intercept. At 4 and 32, 4 and 32 is somewhere around here. Sorry, why did I put a maximum here? 0, 0 is not a maximum, it's a minimum. It's supposed to be going up, right? This is 0, 0. Minimum means is up. See, minimum means up, maximum means down. Okay. And at 4 and 32, which is somewhere around here, I'm estimating, okay? Graph is not drawn to scale. 4 and 32, we have a maximum. Right, so now we join these two. Remember, it's a cubic function. Uh, okay, that should suffice, right? That should be good. And just try to, draw your graph. Obviously, you have more control with your pencils drawing the graph. And by the way, this is not a straight line, it's curving, right? So, and it's going down, right? And this is my cubic function with all the important key features. There's 0, 0, right? That's 4 and 32. You can find the x-intercept, the y-intercept. You can even find the inflection point here. Inflection point is finding the double derivative. Let's just do it for this example. F double prime x. 2 times minus 3 is minus 6. Minus 6x plus 12 is equal to 0. Now, if you solve this, minus 6x equals minus 12. So x is equal to 2. So the inflection point is at 2. 2 and what? You need to substitute 2 inside the original function. So that's minus 8. 6 times 2 squared, so plus 24. 6 times 4. So you will get 16. 24 minus 8, which is 16. And right, that is 16. So 2 and 16 is my inflection point. Okay, guys, makes sense. Right. So that is how you go about sketching cubic graphs. Right, I had one more question on cubic functions. So I'm just going to change this to question number, make that 52. So we just did this question 50, right? What about sketching these types of cubic functions, simple cubic functions, right? You know, like how you sketch a graph of y equals x squared, and then you transform them. How would I go and sketch a simple cubic function like this? Right, so it's kind of like using transformation to sketch. So if you start off with a graph of y equals x cubed, let's try to think about the graph of y equals x cubed, right? And how do I sketch? I say choose some x values and some y values, right? So I'm going to choose some x values, which is -1. Let's choose from -2. -2, -1, 0, 1, 2. So if I put -2 inside here, I will get -8. Put -1 in here, I will get -1. Put 0 in here, I will get 0. Put 1 in here, I will get 1. Put 2 in here, I will get 8. Right, so what does this graph look like? Now remember, we can't apply calculus here. We can't apply first and second derivative because we're trying to investigate what the shape of this graph is without putting any B, C, D, E values, right? Remember, the full form of this equation is ax squared plus ax cubed plus bx squared plus cx plus d. So there's no B, C, D values. There's only one A value. So how will I go and sketch this cubic function? To sketch this cubic function, see what the sketch looks like. You have to use table method here now because all your rules are failing. You're just going to get all your answers to be 0, 0, 0. You'll get a single point. So when it is 0, it is 0. When it is 1, it is 1. Okay. When it is -1, it is -1. Okay. When it is -2, it is -8. When it is -2, it is -6, lower down. When it is 2, it is 8. Now, you can't go and join those three lines as it is. So you need to take values in between. When it is half, it is 1/8. Can you see? When the value is half, remember this is -1 and that's -2. So what happens when the value of x is half? What if I choose the value of half? Half cubed is 1/8. So you're going to get an answer which is very tiny here. And what if the value is -half? Uh, so you can see how the graph turns. So you're going to go and draw a graph. See, if you join these points, you're going to do it like this. Okay. That's what the graph looks like. So it's coming here, there, right? And that's your graph. That's a cubic function. See this piece over here near 0, what's happening? Okay. So this is a graph with no stationary points. Okay. And why it is no stationary points? Because it's always increasing. You can see this graph is only increasing. It's only increasing, right? So what about y equals -x cubed? Y equals -x cubed is a graph which is in the opposite direction. In other words, it's a reflection on the y-axis. Okay. It's a reflected graph. It's a reflection on the y-axis. Why is a reflection on the y-axis? Because you can clearly see the y value became negative here. See there. No, sorry. It's going to be a reflection on the x-axis. If the y value becomes negative, it's a reflection on the x-axis. So this piece is going to move up here. So you'll get a graph like this. Okay, so this is y equals -x cubed. You can show some points here. If I choose a point -2, I will get 8. If I choose a point -1, I will get 1. Yeah. So everything's good. This is y equals negative x cubed. Now, think about this graph. X plus 2 all cubed plus 1. It means I'm shifting this graph right. We want to sketch this graph, and it's basically taking this graph that we have here. Right. I'm taking this graph, shifting it 2 units to the what? 2 units to the left. So transforming y is equal to x cubed, transforming y equals x cubed, translating. So we're trying to use transformation, right? So translating y is equal to x cubed, 2 units to the left and 1 unit up. So if you move 2 units to the left, it's going to be +2 on the inside, and 1 unit up, you can move 1 unit up. So you're moving this graph 2 units to the left and 1 unit up. So the shape of the graph is going to be exactly the same. You're just moving the points up, right? And then 2 units to the left. So let's take this out. And use transformation to sketch, right? So before, if you're looking at this function here, before it was 0, 0, right? So now 0, 0 will move towards -2, 0, right? Remember, in this case, we're also going to have a y-intercept. Don't forget about the y-intercept, right? My x-intercept, will I have an x-intercept here? Oh yes, by the way, -2, 0 is not, you can use that information to sketch the graph, but the thing is, your x-intercept will change. Yes, your x-intercept will change. So let's see. We can't really say the x-intercept is at -2, 0 because we have an x-intercept here. What's a y-intercept? Y-intercept is making x 0. You're going to get 9. My x-intercept is, don't try to open this entire equation up. Is x plus 2 all cubed plus 1 is equal to 0. Take everything over. X plus 2 all cubed is equal to -1. X plus 2 is equal to cube root of -1, okay? Which is -1. So x is equal to -1, -2 is -3. So if x value is -3, yes. If x value is -3, then I am getting an x-intercept here. So that was important to solve. And then we can do all the transformation now, right? So -3 is actually where my x-intercept is because I'm shifting the graph as well. And 9. But it's still a single piece of the function, right? Why is it going like that? Okay. And you can show one another point that lies on the graph like this. Remember this point over here on the main function, it was 2 and 8. Well, 2 and 8 is already shown here. 2 and 8 becomes that. Show another point. let's say this point was, remember this was 2 and -8. No, show the other point, which is -1 and -1, right? Show -1 and -1, how that transforms. So -1 became -3, 0. Even that's not working out. Yeah, just show -2 and -8 then. If I show -2 and -8, it will go to -4 and 7 because you're moving one up. -4 and 7. Okay. And -4 and 7 does lie on this cubic function. -4, sorry, -4 and -7 lies on the cubic function. Let's check. If I substitute -4 inside here, -4 plus 2 is -2 all cubed is 8. Again, yeah, -2 all cubed is -8 plus 1 is -7. Yes. So this is my cubic function. Okay. We just use translation. Note, like how you have uh, this is another form of a cubic function, which is represented y is equal to a into x plus p all squared plus q. When we say something like this, we are looking at a parabola, right? With turning points at p and q. Let's just say negative p now. If this is negative p, so you take the opposite sign from here and there. So this is the parabola in vertex form, p and q, right? Now, if you're looking at observing this, +2 and +1. So what's happening at -2 and 1? It's like it's changing concavity, isn't it? It's like changing, it's going from it was concave down to concave up. Yeah, so it's kind of like changing concavity here. That's -2 and 1. So -2 and 1. So let's look at this cubic function over here. What if we put this -p all cube plus q? So in a cubic, what does this represent? It represents a single curve, right? With not a concavity. It represents a single curve with a concavity change, right? So what's the concavity change here? P and Q. Now what's the concavity change? See, this part here is concave down, right? And see, this part over here is concave up. So you can see this is still on the up part. So this is a happy part, right? It's like half happy and this is like half sad. So it represents a concavity change. So any cubic function in this form is a concavity change, okay? Right, so concavity change is at P and Q. Over here, we have a turning point change, which is at P and Q. So that's the difference between those two functions. And we can clearly see that is happening here as well. Right. Now, that's good stuff. Excellent. Next part, guys. Yeah, I want you to look at this question from this question appeared in the Eastern Cape trial paper, right? 2018. I also have questions from IB as well, right? So it's not only I'm not only focusing on the NSC papers. You need to focus on IEB as well because they have some excellent questions, really good questions for you to think about, which can come out in your, in your trial exams. So let's look at this question number 52. Oh yes, by the way, What we are now looking at is analysis of functions, analysis. We're not sketching the graph. The graph is sketched. We have to find the equation. Analysis finding the equation, not analysis of function. We are now looking at finding the equation of functions. Finding the equation. Now, what is finding the equation of a cubic function? Very simple. First, if we are given x-intercepts plus a point, example, right? All the x-intercepts are given and a point is given. So what does that mean? It means that, okay, we have a line, right? 1, 2, 3. All three x-intercepts are given and a point is given. Another point P is given somewhere around there. So we need to start off with this equation, y equals a into x minus x1 into x minus x2 into x minus x3. If that's the scenario. Now you have another scenario. Or what if the turning point is on the x-axis, okay? What if your turning point is on the x-axis? Example, you have a cubic equation like this. Okay? And you have another point over here. So basically, you only have two x-intercepts now because one turning point is on the x-axis. You got x1 and you got x2, right? And obviously some other point is given, point P is given. Why we have to substitute the third point? We have to substitute the third point to find the value of A. So what equation do I use here now? So I say y is equal to A into x minus x1 squared. Why squared? Because this here appears twice. Whenever you have something twice, x-intercept twice is always on the x-axis. The turning point is on the x-axis. TP on x-axis. Right. After you get x minus x1 all squared, you need to say x minus x2. So that makes 3 x-intercepts, okay? Because this is twice and this is once. Right, so those are the two scenarios. Note. Now let's observe a turning point. What if I have a turning point on the x-axis? Sorry, what if I have a general turning point? Let's just say if I have a turning point over here. Let's just say if this point is 4 and negative 5. So what we know is that the turning point has two equations. First equation is that the slope at the point is 0. The gradient at x is equal to 4 is 0. How are you going to write this out? You're going to write this out as f of 4 is equal to negative 5, f prime. And what about 4 and negative 5? That's just a direct point. So the direct point is f of 4 is equal to negative 5. So two important things. Sorry, f prime 4 is not negative 5, is 0. So turning point has two equations. The first equation is f of 4 is equal to negative 5. And f prime 4, the gradient at 4 is 0. Are we good, Mishka?
Yes, sir.
Right. Now let's solve this question here because that's what they're going to ask us for. Right, so we have this graph here. Okay, I just need to copy this because I need to apply this graph everywhere. Now, let's go back. The sketch below shows the graph of h of x, right? So the cubic function is given. You can check the shape of the cubic function. It is positive. C and E, right? C and E are the turning points of H. C and E are the turning points of H. Just 1 second. Right, so what we have here is that we know that C and E are the turning points of H. The function is H, right? So what does turning point mean? Turning point means that the derivative must be equal to 0. That's how we find turning points. Right, so those are all the important information. Turning point means that the derivative must be equal to 0. That's how you're going to find the turning points. And F are the x-intercepts of H. A is a y-intercept, right? So everything is given. You know what B, D, and F are. That's the x-intercept, y-intercept, turning points. That's it. Now let's see. Because the entire cubic function is given, it's easy to basically analyze this graph. There's hardly any unknowns. So question number 1. Remember 4 marks, easy, right? So see what the first question is asking us for. Determine the x coordinates of the turning points of C correct to 2 decimal places. Determine the x coordinate of the turning point C, right? Correct to 2 decimal places. In other words, the quadratic function, they know that it's not going to work out. So they want you to find that. So A, we only want of the point C. So we need to find f prime x, the derivative, because at C and E are the 2 stationary points. So we have a stationary point here, right? At C and E, those are stationary points. So we know that the derivative must be equal to 0. What is the derivative? 3 times 1 is 3. So we have 3x squared. 2 times minus 9 is minus 18x plus 23, right? Because 23 times 1 is 23. And the derivative of constant is 0. So remember, they want you to find this. So you have to use a quadratic formula. Minus b is 18 plus minus square root of b squared minus 4ac. A is 3, C is 23, divided by 2 times 3. You have to use that. But I wouldn't go and type out this entire thing into the calculator. I'll just use a cheat method. So mod 5, 3. I'll say 3, negative 18, and 23. So I'll get 2 answers, right? So the 2 answers I'll get is 4.15, x equals 4.15, or x equals 1.85. So we can clearly see that this point here is not applicable over here. So the x value should be 1.85, right? If you type this entire thing into the calculator, you should get the same thing, right? Next, I just use a quadratic formula here, put it there, but it's too long to type. So I just use a cheat method. I'm just showing you how to solve questions quickly. If the x coordinate of B is 1, if the x coordinate is 1, determine the coordinates of F. So see what they're trying to do here now. The x coordinate is 1, determine coordinates of F. We still gotta go and solve this entire equation equal to 0. So x cubed minus 9x squared plus 23x minus 15 is equal to 0. Now they already gave us one answer. Okay, so open 3 brackets. So they're telling us x is equal to 1, so you can put 1 inside here, x minus 1. Now let's just use our cubic function, mod 5, 4. Enter all these values, 1, -9, 23, -15. So you're getting 1, 5, and 3. Right. So that's x minus 5, x minus 3, that's x minus 1. All right. So bring everything over, open this up. X squared minus 8x minus 5 times minus 3 is plus 15. Okay. So now everything works out. So what's the coordinates of D? D is 5, 0. No. We want the extreme point, which is F. Point F will be 5, 0. So not applicable, not applicable. Right? So F will be 5, 0. Okay? Okay, you don't need to write not applicable, not applicable, because you know this is what did they want? Determine the coordinates of F. F is 5, 0. Let me just put a 5 here, and that's a 3. So we got 1, 3, and 5. All right, great. Next question. See what this question is asking for. Okay. The graph of H is concave down for x is less than k, right? So it is concave down somewhere, right? So we need to find the double derivative. Let's find the double derivative. We had this first derivative, which is f prime x. We copy that here. What is f double derivative? F double derivative, 3 times 2 is 6, 6x minus 18. And when is it concave down? It is concave down when double prime x is less than 0. Isn't concave down? And greater than 0 will be concave up. Remember I showed you that. When is it concave down? Concave down when double prime x is less than 0. So just solve the equation less than 0. So you got 6x less than 18, take that over. So x is less than 3. So calculate the value of k. This implies k is equal to 3. Easy. Okay. Last question. All right, so I'm going to elaborate a bit on this question here, right? So I determine the equation of the tangent at D in the form y equals. What's the equation of the tangent at D? All right. So at D, what is the coordinates of D? 3, 0, which is the point of contact. All right. So D is point of contact, which is 3, 0. We need a gradient. Remember, we're trying to find y equals mx plus c. All right. That's what you're trying to find. What is the gradient? Gradient is equal to f prime x. And evaluated at x is equal to 3 because the known point is 3. What is f prime x? F prime x we already know. F prime x we already know is 3x squared minus 18x plus 23. Right, we already know that f prime x is 3x squared minus 18x plus 23. Now, to find the gradient, we got to substitute the value of 3 inside here. We got to substitute it into f prime 3. So substitute 3 inside here. You're going to get 3 into 3 squared minus 18 times 3 plus 23. We're getting -4. So great. We have now the gradient, which is -4. You can clearly see the equation of the tangent is like this. See, we got a tangent here at -3. So you can see it's a downward sloping line. That's the tangent line, okay? The slope is downward sloping. Yeah, so the gradient is -4, and you can see it's a downward sloping line. So you're going to say y minus y1 equals m into x minus x1 at the point D, which is 3, 0. Now, remember, this is x1, that's y1. y1 is 0, so y minus 0. What's m? -4. X minus, what's x1? x1 is 3. So we are getting y is equal to -4x plus 12. Right, so that's the equation of the tangent. Equation of the tangent. Right, guys, make sense? Right, so I hope you understood this question. Very nice question. And right, this brings us to the end of our session. Arnav, we good?